Here's an example of graphing a secant function. So in this video we're going to use a set of steps here. So it's the same paper from the tangent and cotangent videos, but now instead of the top box we're going to use this box here because it's for secants and cosecants. If you want a copy of this to follow along with, check the video description. There's a link in there you can click to open this up and you can print it out and follow along if you like. We are also going to use some graph paper here, so if you want to follow along with some graph paper near the end, there's a link for this in the video description also, so you can click that link and open up some graph paper, print it out if you'd like. So anyway, let's just jump right in here. So step one, find the period t equals 2 pi divided by the absolute value of omega, and find the general equation of the vertical asymptotes. Okay, so we talked in detail about both of these things here in earlier videos. So we know that for secants and cosecants in general, the period is 2 pi divided by the absolute value of omega, where omega is the thing being multiplied by the x. And also we talked about how to find the general equation of the vertical asymptotes in a separate video, so we're going to go through the exact same process here, but we won't explain the details behind it because we don't want to spend too much time on things like that we've already done. Okay, so anyway, want to identify the period t equals 2 pi divided by the absolute value of omega. So remember, omega is the thing being multiplied by the x. What is being multiplied by the x? Well, here it's pi over 3. So omega for us, for this specific example, is pi over 3. Okay. Okay, so then first we say the period t equals, remember, 2 pi divided by absolute value of omega. Okay, well, omega is already positive, so we don't need the absolute values. So this is 2 pi divided by pi over 3. Okay, so parentheses around that. So if you divide by pi over 3, that's you're just multiplying by the reciprocal, 3 over pi. So 2 pi times 3 over pi. The pi's cancel, and we have 2 times 3, which is 6. Okay, so that's good. That's a relatively simple period, not too bad. That's good. Okay, now what? Well, now the rest of step one is find the general equation of the vertical asymptotes. Okay, so we're going to do it just like we did in those other videos where we talked about how to find those. So first what we say is original, as in the original general equation of the vertical asymptotes for just plain old y equals secant of x. Okay, so for just y equals secant of x, the equation is x equals k pi plus pi over 2, where k is any integer, abbreviated int for short. Okay, so that's for just y equals secant of x. Okay, we don't have secant of just x, we have secant of this big mess here. So what we do is now we say new, okay, the new general equation for our new secant function that we're given up here. So the new one is, what we do is, remember, we take everything inside of the secant, take this whole thing inside of the secant, which is pi over 3x, oops, pi over 3x plus pi over 2, and set it equal to k pi plus pi over 2. Okay, so we talked a lot about why we do this in a separate video where we explained how to find these things. So anyway, take the entire expression inside of the secant, which is pi over 3x plus pi over 2, and set it equal to k pi plus pi over 2, where again k is any integer. Now we just solve for x, okay? Because what are we doing? We're looking for the general equation of vertical asymptotes, so we have to have x equals something, and it's going to have a k in it, okay? Because it's general, so it should have a k in it. So anyway, solve for x. So subtract pi over 2 from both sides. That's good because now both these pi over 2's are gone. So we have pi over 3x equals k pi. Okay, now we just want to get the x by itself, so multiply by 3 over pi. Okay, so cancel, cancel, and then multiply by 3 over pi. Pi is cancel. So what we have left is x equals 3k, where k is any integer. Okay. So that is beautiful. That is a great general equation. X equals 3 times k. It really does not get a whole lot simpler than that. That is truly wonderful. Okay, now that's it for step 1. Find the period and find the general equation of the vertical asymptotes. Now step 2. This is a little bit different from tangent to cotangent. So for step 2, for secants and cosecants, now we find 3 consecutive asymptotes by plugging k equals -1, k equals 0, and k equals 1 into the general equation. So remember, for tangents and cotangents, we only found 2 consecutive asymptotes, but now for secants and cosecants, we find 3. Okay, so that's actually going to make the rest of this pretty relatively simpler. But anyway, so again, just like with tangents and cotangents, we don't have to use those specific values of k. Okay, but it's good to keep it as simple as possible. Stay near the origin if we can. So as long as we use 3 integer values of k that are right next to each other, so -1, 0, and 1, or 0, 1, and 2, 1, 2, and 3. We could even use 112, 113, 114. Okay, those are too far away to be really what we want to use, but it's still possible like that. But they're not really as simple as we can have. And we do want to stay near the origin, so we should use -1, 0, and 1, generally speaking. Okay, so anyway, set up our chart like we always do for this. K, vertical asymptote. So we're going to use -1, 0, and 1. And it's going to be relatively straightforward, which is really nice. So now we figure out, okay, what's the vertical asymptote? So when k is -1, we have x equals 3 times -1, which is -3. Okay? So here, x equals -3. Now again, it's the equation of a vertical asymptote, so we don't want to just say -3. Make sure we say x equals -3 so that we're being safe and thorough and everything. Okay? So it's a vertical asymptote, it's a vertical line, so we're given the equation of a vertical line. So don't just put numbers here, we have to make sure we say x equals a number. Okay, so that's when k is -1. What about when k is 0? Well, then x equals 3 times 0, okay, which is just 0. So x equals 0. Now what about when x is 1, or sorry, what about when k is 1? Then x equals 3 times 1, which is just 3, so x equals 3. Okay. Okay, so let's erase this, because we're going to use that space for something soon. Okay, that's it for step 2. Find 3 consecutive vertical asymptotes by plugging k equals -1, 0, and 1 into the general equation. Now step 3, take the first and second asymptotes and divide the interval between them in half to get an x value. Do the same thing with the second and third asymptotes to get another x value. Okay, so that kind of sounds like a mouthful, but it's actually pretty simple. And what we're going to do is set up our chart kind of like we did at this step for tangents to cotangents. Okay, but now our chart has 3 asymptotes on it. So it has -3, +3 is over here, and then exactly halfway in between them is going to be 0. Okay, so because we use 3 consecutive asymptotes, we have 3 numbers like this here. Okay, so now what we want to do is, remember the step said take the first and second asymptotes and divide the interval between them in half to get an x value. So here's the first and second asymptotes right here, x equals -3, x equals 0. Divide the interval in half to get an x value, okay? So we can always just, so we don't even really have to think of it like that. Just set up the little interval like this, set up the little chart like this, put so first asymptote, second asymptote, third asymptote, divide this interval in half to get an x value. Do the same thing with this one, okay? Divide the interval between the second and third asymptotes in half. Okay, but first let's look at this. So -3 and 0, we want to know what's exactly halfway in between them. Well, add these guys up and divide by 2. So -3 plus 0 divided by 2, that's just -3 halves. Okay, so this is -3 halves. Okay, now do the same thing between the second and third asymptotes. Divide the interval in half. So what number is exactly halfway in between them? Well, 0 plus 3, and then divide by 2. Okay, so 0 plus 3 divided by 2 is just 3 halves. So this right here is just 3 halves. Okay? Okay, so that's really it for step 3. Okay, so now step 4, find the y values at the 2 x values found in step 3. Okay, only do those 2 because the asymptotes are at the other 3 x values. Okay, so when we did step 3, we found these 2 new x values here, -3 halves and +3 halves. Now we're going to find the corresponding y coordinate on the function, okay, at these x values. But we can only do these 2 x values because there's a vertical asymptote here, and here, and here. Okay, so we cannot plug this number, or this number into the equation because the function's undefined there because it has a vertical asymptote. So we can only do it with these 2 numbers, okay? So actually, in that sense, this is a little simpler than tangents to cotangents because we can only evaluate at 2 of these numbers and not 3 of them. So that's kind of nice. Okay, so anyway, let's go ahead and do that now. So set aside some space here. So we're going to evaluate the function at -3 halves and +3 halves. So when x equals -3 halves, what is going on? Let's figure out what's going on. So what's going on is y equals -2 times the secant, I'm worried I'm not going to have enough room here, of pi over 3 times -3 halves, and then plus pi over 2. And then we have a -1 out there. Just barely enough room. Okay. Okay, so then this equals Negative 2 times the secant of what? So 3 and 3 cancel, so what we have is pi times negative 1. Okay, so this is really negative 1 right here. So negative pi over 2 plus pi over 2 becomes 0. Okay, so then this is where our knowledge of the unit circle comes in handy. So remember that secant, if you have trouble with that, just remember secant is 1 over cosine. So secant of 0 is the reciprocal of cosine of 0. So in other words, secant of 0 is 1 over cosine of 0. But no matter how you think of it, secant of 0 is 1. So this is negative 2 times 1, and then minus 1. Negative 2 times 1 is negative 2. Negative 2 minus 1 is negative 3. Okay? So when x is negative 3 halves, the corresponding y-coordinate is negative 3. Negative 3 halves, comma, negative 3. Okay. Now what about when x is positive 3 halves? What's going on there? So when x equals positive 3 halves, let's figure out what's going on. What we have is y equals negative 2 times the secant of pi over 3 times positive 3 halves, and then plus pi over 2, and then minus 1. Okay. So now this is going to equal negative 2 times the secant of, so pi over 3 times 3 halves, so 3 and 3 cancel, we're just left with 1 up here. So this is pi over 2 plus pi over 2. So pi over 2 plus pi over 2 is 2 pi over 2. 2's cancel, we're just left with pi, so this is secant of pi, and then minus 1 still. Okay. So again, knowledge of the unit circle really comes in handy here. So secant of pi is negative 1. So this is negative 2 times negative 1, and then minus 1. Negative 2 times negative 1 is positive 2. Positive 2 minus 1 is 1. Okay. So when x is positive 3 halves, corresponding y-coordinate is positive 1. So this gives us the point 3 halves, comma 1. Okay. Okay. Now that's it for step 4. Okay, so we see that's nice. We only had to evaluate the function at 2 x values. Now step 5, if a scale is not set up on the graph, let the x-axis scale be t divided by 8. Okay, so for tangents to cotangents, we used, remember, t is the period that we found in step 1. So for tangents to cotangents, we did t divided by 4, but for secant to cosecants, we're going to do 8, and we'll see why once we graph it. Hey, you actually can still use t divided by 4, or technically speaking, anything you want, as long as it's convenient enough for you. But t divided by 8 is a little bit better than t divided by 4. We'll see why once we graph it. Also, let the y-axis scale be something convenient and relatively similar. Graph the asymptotes, plot the 2 points we found in step 4, and use them as guides to draw the graph. So we'll see how that works. So let's pull out our graph paper. I'm actually going to use this one that's already ready-made from the mistake from the cotangent video. So anyway, have our y-axis here, x-axis here. So, well, before that though, let's figure out what our scale is. So if t is 6, okay, t equals 6, so t divided by 8 is 6 divided by 8, and then if we reduce that, that's going to be 3 over 4. Okay, so our x-axis scale is going to be 3 over 4. What does that mean? What that means is every one grid box is going to be 3/4 of a unit. Okay, so that's actually going to be kind of a mess. That won't be that bad. Okay, so 3/4, and then this is going to be another 3/4, so it's going to be, zoom in a little bit. So it's going to be 6 over 4, which actually reduces to 3 halves. Okay, this is going to be 9 over 4, which does not reduce. Okay, and then this is going to be 12 over 4, which reduces to 3. Okay, and then this is going to be, let's see, 3, 6, 9, 12, 15 over 4. Let's stop there, and then we'll go the other way now. So this is negative 3 over 4. This is negative 3 over 2. This is negative 9 over 4. Okay, so same exact scale, just going in the negative direction now. So 3/4, negative 3/4, 3 halves, negative 3 halves, 9/4, negative 9/4, positive 3, negative 3. and then positive 15 over 4, negative 15 over 4. Okay. Okay, now let's set up our y-axis scale to be something relatively similar and convenient. So 3/4, what are our y-coordinates? Our y-coordinates are -3 and the other y-coordinate is +1. So 3/4 is close enough to 1, so let's just let each grid unit in the y direction be 1 unit. So each grid box in the y direction will be 1 unit. So this is 1, 2, 3, 4, 5, 6. I think that's good there. And then -1, -2, -3. Okay, so -1, -2, -3, -4, -5, -6. Okay. All right, that's good enough there. Let's zoom out just a bit. Okay, now, remember, okay, so if the scale is not set up on the graph, so if you're doing this on a quiz or a test, you might be given the scale already just to save time, because there's more important stuff going on here for trig. So anyway, we let our x-axis scale be t divided by 8. We haven't explained that yet, but we'll explain it once we start graphing. So now first we graph the asymptotes, because we set up our scales on the x and y axis. Okay, so graph the asymptotes and then plot the 2 points and use them as guides to draw the graph. So first let's draw those asymptotes. So remember they were, so we kind of erase them here, but we'll zoom out a bit. So remember they were x equals -3, x equals 0, and x equals +3. Okay, we found those earlier in an earlier step. So now let's go ahead and graph those. Okay, so zoom back in here. Okay, so x equals 0, that's right on the y-axis. Well, that is the y-axis. So x equals 0. Okay, and x equals 3. This one right here. So even though it's clear what it is, we should label our vertical asymptote because there are vertical lines, and we do want to be safe and thorough, so let's label those. And also x equals -3. Okay, we're going to get that one too. And so again, label that as well, so x equals -3. Okay, now we're going to plot those points. So what were the points? They were -3/2, comma -3, and +3/2, comma 1. Okay. Okay, so -3/2, comma -3 is right here. And then +3/2, comma +1 is right here. Okay. Okay, now where do we go from here? How do we use this as a guide to draw the graph? Okay, so first of all, let me explain. Remember the general shape of secants and cosecants? So remember they have this. So they have asymptotes. Then they open up sort of like a parabola. It's not exactly a parabola, but it just kind of looks like that. Has that same curvy shape. Okay, so x-axis, y-axis up here. Okay, so they got that kind of repeating thing going on here because of the periodic properties, and they also have this parabolic shape. It's not exactly parabolic, it's not really parabola, but it just sort of looks like one. Anyway, we're going to use these points as guides. Okay, so here, this point is below this point, so from this point, everything's going to open down like that. Okay, it's going to open downwards like this piece here, or like this piece right here. Okay. And this point up here, since it's further up, everything's going to open upwards up here. Okay, it's going to open upwards like an upwards U shape. Okay, just like this piece, or like this piece right here. Okay, so that's what's going on there. Now, the reason we did t divided by 8, okay, remember we did t divided by 8 for the x-axis scale, because if we did t divided by 4, what we would have is an asymptote, this point, an asymptote, that point, an asymptote. So there wouldn't really be enough room to open this up wide enough. Okay. So how do we know how far wide we need to go? Well, if we need to be really specific, we can start plugging in these values, okay? So if we plug in -9/4, -3/4, +3/4, +9/4, we're not going to do that here, okay? It might not always work out so nice, and actually in this case it'll work out okay. Okay, so if we plug in 3/4, we can take that, plug it into the function, get the corresponding y-coordinate. Okay, but we don't really want to worry about being that specific here. But if you have to be that specific, you can go ahead and do it. Okay, so again, just if you need to plot more points, then take 3/4, 9/4, -3/4, -9/4, put them into the function. Okay, simplify, evaluate, things like that. If everything works out okay, you should be able to get nice numbers that are on the unit circle. Okay, it should always work out like that, hopefully. If everything goes right. So anyway, now just use these as guides. So remember, this one opens downwards like this. Remember, approach the asymptote but never touch it. And be careful, we do have an asymptote right here. Okay, that's much better than tangents and cotangents, that's for sure. Okay, and up here, open up like this, approach the asymptote, never touch it, and open up like this. Yeah. Approach the asymptote, never touch it, be careful about that. Okay, okay, so zoom out a bit, and that's really it for the graph. Okay, that's it for step 5. Now step 6, use the period and general equation of the asymptotes to graph more cycles if necessary. Okay, so k equals -1. Okay, this is all erased, I guess, but when we did k equals -1, we got this asymptote. K equals 0 gave us this asymptote. K equals +1 gave us this. K equals +2 gives us the next one. K equals +3, the next one. K equals 4, the next one, and so on and so forth. K equals -1 gave us this one. So k equals -2 will give us the next one to the left. K equals -3, the next one to the left after that, and so on. Okay, but we don't really have to do that. We can just use the period. Okay, so remember the period is 6. So every 6 units, everything's going to start repeating. Okay, so and we actually kind of see it on the graph already. So x equals -3. If we go 6 units to the right, we're going to have another vertical asymptote. Okay, at x equals +3. If we go 6 more units to the right, we'll be at x equals +9, and we're going to have another vertical asymptote. Okay, so let's oh, and also at x equals -3, if we go 6 units to the left, we'll be at x equals -9, and we'll have another vertical asymptote. Okay, here's x equals 0, go 6 units to the right or to the left, there's another vertical asymptote. Okay, so let's extend one cycle to the right and one cycle to the left. If you're not interested in doing that or seeing that, that's pretty much it for this video then. But if you want to see extending this one cycle to the right and to the left, we're going to do that right now. Okay, so anyway, we need to continue with this. So 3/4, 6/4, 9/4, 12/4, 15/4, and then this is 18/4. Okay, which is 18/4 that reduces to 9/2. Okay, if we pull out a common factor of 2. And then this is 21/4. Okay. And then this right here is going to be 24/4, which reduces to just plain old 6. That's good. Okay, so right here is actually another vertical asymptote. Okay, because remember, there's one at x equals 0, and the period is 6. So if we go 6 units to the right, everything's going to repeat. So we have another vertical asymptote right here. So why not draw it now? Okay, or we could have taken our general equation for vertical asymptotes and plugged in k equals 2. Because if we, oh sorry, I knew I shouldn't have said that. Okay, because if we plug in k equals 2, remember the general equation here, it's all erased from the graph, but it's graph paper, but it's x equals 3k, where k is any integer. So if we plug in k equals 2, okay, then when k equals 2, we're going to get x equals 6. Okay, so remember here we had x equals -3, x equals 0, x equals +3. For k equals -1, 0, and 1, then k equals 2 will give us x equals 6. Okay, so a couple different ways of going about doing this whole thing. Okay, but anyway, zoom in a little more here. Okay, so this was 24/4, this will be 27/4. Okay, so remember, each one grid box is 3/4 units. That's why I'm counting in multiples of 3 divided by 4. 7/4. 30/4 is 15/2. 33/4. Ugh. And then 36/4. So 36 divided by 4 is going to be 9. Okay. And again, we have another vertical asymptote at x equals 9 because we have one at x equals 3, and then if we go 6 units to the right, we're at x equals 9. Okay. So x equals 9. Okay, now zoom out a bit. Okay, so now let's use the period to extend these here. So right here, exactly halfway in between the asymptotes, we know the y-coordinate is going to be -3. Okay, so that's right here. So this piece, if we use the period, is going to translate over to this piece right here. To make it look the same. And again, if you want or if you need to be more precise than this, just take these x-coordinates and plug them into the function. Or it's maybe easier with these x-coordinates here. Okay, take -9/4 or -3/4 and plug them into the function. Okay. and that'll give you the exact y coordinates. You can be a little more precise here, but it really doesn't matter for the example that we're doing here. But if it does matter for what you're doing for your class, if for your homework or anything like that, be very careful about that. You may need to be more specific and more precise than we are in the video. Okay, so then here, okay, so this piece right here got translated over to this piece from the period. Okay? And then this piece right here is going to become this piece over here from the periodic properties. Okay, so open up kind of the same way. Remember, approach the asymptote, approach the vertical asymptote, never touch it. Vertical asymptotes can never be touched or crossed. No exceptions. Okay, so that's so right here, okay, we started with one complete cycle. Now we just duplicated that one complete cycle to the right. Okay, now let's take this and go one complete cycle to the left. So it's going to be all the same numbers as over here, but negative. So this one is negative 9 over 2. And then this one's going to be negative 21 over 4. This guy is negative 6. And then negative 27 over 4. Negative 15 over 2. And then negative 33 over 4. And then negative 9. Okay, so I was just looking at all these numbers over here and making them negative to go this way in the negative direction. So again, since there's an asymptote at x equals 0, if we go 6 units to the left, because the period is 6, we go 6 units to the left, we're going to have another vertical asymptote at x equals negative 6. Okay, x equals negative 6. And then here there's one at x equals negative 3. So if we go 6 units to the left, we're going to be at x equals negative 9, where there's another vertical asymptote because of the period. Or again, we could just use other values of k in our general equation of the vertical asymptotes. So remember, k equals 0 gave us this one, k equals negative 1 gave us that, k equals negative 2 would give us that, k equals negative 3 would give us this one. Okay, now we just use the period to extend the graph again. So this piece is going to become this piece right here. So this point, negative 3 halves, is exactly halfway between the asymptotes. This point here, exactly halfway between the asymptotes, so same y coordinate. And again, if you're not okay with that, you just use the period. Negative 3 halves minus 6, okay, because we go 6 units to the left, so negative 3 halves minus 6. Get a common denominator, multiply 6 by 2 over 2. That's negative 3 halves minus 12 halves, which is negative 15 halves. And we see that is the x-coordinate right here, negative 15 halves. Okay. So if we zoom in, we see that right here, negative 15 halves. And same y coordinate. Okay. So open it up kind of the same way, or exactly the same way. I say kind of because it's just a rough sketch that I'm doing and I'm not doing a very good job, as we can see. Alright, well, still better than tangent and cotangent. Can't stress that enough. Anyway, so now we also move this piece over. So 3 halves minus 6 is going to give us negative 9 halves. Okay, so same y coordinate of positive 1. So this opens up the exact same way. Remember, approach the vertical asymptote, never touch it. Be careful about that. Okay, so that's so we started with this cycle here, then we extended it one cycle to the right, and then we extended it one cycle to the left. So now we have 3 complete cycles of this graph, of this function on this graph here. Okay, so this is the function y equals negative 2 times the secant of pi over 3x plus pi over 2, and then minus 1. Okay, so we see it's a little bit simpler than tangents and cotangents because we only evaluate at 2 x-coordinates, right? Because we have 3 asymptotes to work with. Okay, so notice in one complete cycle we have 1, 2, 3 asymptotes. X equals negative 3, x equals 0, x equals positive 3. Okay, so that's nice to have that. It simplifies things a little bit. And again, if you have to be more precise or more specific about the shape of the graph, then plug in these x-coordinates. Okay, take these x-coordinates, 3/4, 9/4, negative 3/4, negative 9/4, plug them into the function to get the specific shape. And again, for the x scale, we use t divided by 8 so that we can have this extra space here. Because if we use t divided by 4, it would all be kind of squished in, which is okay, I guess. But still, it's nice to have it stretch out a little bit so that we can more easily see the shape, have more room to work with, especially on a grid this small. So anyway, that's really it for graphing a secant function. More stuff coming up next.